Hello guys, this is Yakov Fein. Today is the lesson number 5 from my training on Java, Introduction to Java. You can see all previous lessons, video recording, by following the link at the bottom of this slide. Today we're going to continue with working with Swing, Java GUI with Swing. So what is Swing? And how do you go about GUI in Java? So far, we didn't create any graphic user interface so far. But what if you need to create a calculator that looks like a window that has buttons and everything else? You need to have some component, some GUI component, graphic user interface component. And in Java, originally there was this library called Abstract Windowing Toolkit back in the 90s. And at the end of the 90s, it was replaced with the Swing framework. Different set of components. They were a bit lighter than the AWT. And then in probably 2009 or 2010, a new development started on the so-called JavaFX framework. And JavaFX is the next replacement, and so far it didn't replace, but most likely in a couple of years people will not be doing Swing, but mainly JavaFX. But for now, Java Swing is the most popular way of developing graphic user interface in Java. Hence, we are covering it today. How do you go about creating windows in Java? When I say windows, I mean not only Windows as an operational system Windows, but any window, any viewport, so to speak. To do that, you need to extend your class from some container, some some GUI container that come with the Swing library. In particular, in this case, we're going to be starting with simple hello world. Check this out. There are classes that are related to Swing in the package Java X Swing. It uses some older classes from AWT framework, but mainly you're going to be using these UI components. In this particular case, I'm using JFrame. JFrame is a container that can hold other components or other containers. So if you want to create a window that looks like on the right-hand side, hello world, it's empty, but it's a window anyway. So we will create a class that extends JFrame. So hello world extends JFrame. So at a bare minimum, we will create a constructor over here, right? Hello world. And in there, we are setting the size of the window. Check it out. We are extending JFrame, right? So the method set size is called from JFrame. And we set a title on that window, hello world. The title of the window is something that you would be seeing over here on the title bar of the window. And finally, set visible true. To show this window, you call this method. That's about it. Then in the main method of your class, you instantiate this hello world, and it works. We will do it now, pretty soon. But for now, just remember, you need to extend your class from one of the visual components or containers, and then you need to instantiate it properly. This container, which is a JFrame, it's a top-level container, and you can put other containers in there or components. For example, you can create, say you want to create a button. JButton is a class that comes with Swing that knows how to render a button. The word render means to show it on the screen. We are rendering GUI components, not we. Java is rendering, JVM is rendering GUI components. So you create an instance of whatever component you want to show, and then you add it to the container. In this particular case, I didn't put anything in front of the method call because it assumes the word this. So which means that I'm referring this container. What is this? This is JFrame in this case, because this code would be executed inside of the JFrame. Again, if I decide to do this. Otherwise, if I would use the same code if I want to do it inside the method main, not inside the constructor, where I could have added my button simply like this. But if I would do it over here, I could add the next line saying my hello dot add my button. Of course, you need to create this button. How the components, the graphical components, are being arranged inside the container. There are two major ways of doing this. One of the ways is you can say, don't help me with arranging. I will specifically enter or program in pixels where the component should start or where the component should end. For example, you can say that I want my component to start at the X position. This pixels, say for example 20 pixels on the X, so it's from the top left corner of the window, will take 50 pixels to the right, and Y X is going down from the top left corner of the window. So if I will say that the left corner of the button should start at the position 50, 100, it means 50 to the right, X is 50 pixels, and 100 down. But the second way, and the more popular way of creating, of laying out components on the screen, is by using so-called layout manager or layout managers. Swing has a number of layout managers that will take care of automatic arrangement of your components on the screen. Why do you even need that? You may need that because in some cases you want to allow users to change the size of the window. So if the user will grab the window and start to extending it or maybe make it smaller, these layout managers gives you a way to make sure that your screen will maintain relative positioning of all components in there. So basically, layout managers is a way to say how to change the layout on the screen if the size screen changes. For example, how do we add? First of all, how do we add a component, and how do we add layout manager to the container? So you need to create an instance of some container. In the previous slide, I was creating an instance of JFrame. In this slide, I give you an example of how would you create so-called panel and add something to the panel. In turn, by the way, this panel later on can be added to the frame. So the JFrame can have one or more panels, right? A panel inside may have one or more components. So this is how it goes. Now, let's see, what are the steps? First, you need to create an instance of JPanel using the regular new operator. Second, you need to assign a layout manager to it, which one we will see in a minute. But you need to say, this panel will be controlled by so-and-so layout manager. Then you need to create instances of one or more components, or we call them controls sometimes, and you need to add them to the panel. After the components are sitting inside the panel, then you add a panel itself to the top level container. In our case, it will be, say, a JFrame. How do you do this? You can say set content pane, the method set content pane, and give the panel to this method. And finally, you can set the frame's size and make it visible. These are the steps. What are the three main actions that you're going to be doing if you are into GUI programming? It pretty much doesn't depend on what language or framework you use. We are using Java, we are using Swing, but if you'd be using something else, you still would need to do these steps. First, you need to create a nice, to the best of your artistic abilities, or maybe according to some spec, you need to create the UI, the nice looking GUI, arranging all the components. Then you need to write the code that will react on events that may be happening with this screen, with these components. For example, you can create a nice looking calculator, but how good is it if you click on the button but the button don't react? So to make them react, you would need to write some code to react on events. These events can be user generated. For example, the user clicks on the button and we need to do something. Or they could be system events. System events is not something that happens because of the user, but it's rather something that happens because maybe the application sends some signals to the screen. For example, maybe the window gets resized. The corresponding events will be firing or dispatched, as we say, under the hood. Actually, no, this is a bad example. Windows gets resized. Most likely it gets resized because of the user action, right? But in some cases, there could be a situation when the window needs to get repainted, not because the user touched the window, right? But because the user added or actually opened another window that is closing this window, right? So there could be different events, different types of events that are going under the hood. Or maybe the data arrived from the server and the data needs to be shown on the screen. User didn't touch the screen, but this is something that has to be done. And of course, if the data arrived from the server, or maybe you did some calculations and it's time to show the data on the screen, then you do this rendering and your program populates the UI with the data. So these are pretty much the three actions or activities that you would need to do to make it work. Let's start creating a calculator. The first version of our calculator will be using so-called flow layout. This may not be the best looking calculator that you've seen so far, but it is a calculator. And my goal is not to sell calculators, but to show you something about Layout Manager. So let's start with a simple one. So this screen has several GUI components. This is the text label, JLabel. Next to it, there is a text field. In our case, we're going to be entering data in there. This 10 means it can hold 10 characters, 10 digits in our case. Then again, JLabel, number 2. Then again, text field. Then again, JLabel sum, and the text field to show the sum. And finally, we have a button add, the J button with add. So let's see what we do over here. First of all, we create a panel. This is a container that will hold inside all these labels and text fields. JPanel, we created an instance. Nobody sees it yet, it's somewhere in memory. Then we create an instance of the layout managers that we want to use. In this case, as I said, we will be using flow layout. There is a number of these layouts, but we want to use flow layout. And then we say, see this variable window content points at the instance of JPanel. We say this JPanel will be controlled by flow layout. We assigning layout to this container. Next, container is ready. Nobody can see it yet, and it has no content inside. So the next step is to instantiate all these controls in memory. Again, nobody sees them yet. They're instances in memory. Now we are adding them to the panel. At this point, nobody sees anything, but the panel is populated. It knows its layout manager, and it's ready to be shown to the world. Finally, we will create a top-level container and put the panel in there using set content pane. window content, it's our panel with all these little components. So we add it to the frame. And finally, we set the size of the frame, in this case 400 pixels width and 100 pixels height. And we make it visible. That's about it. That's about it. There's a whole bunch of other layout managers. As you can see, flow layout, grid layout, box layout, border layout, card layout, grid bag layout. And we'll go over them today. But for now, just we are trying to do very simple calculator using flow layout. What is the flow layout? Flow layout is, it's like go with the flow. We have a container, JPanel, and the program gives to this container a label. It'll put it on top, imaginary row starting from the left. Then we want to add another control, say text field. It'll try to fit the control on the same imaginary row. If it fits, we have a certain width of the window, right? Let's say it's fit. We want to put another one and another one and another one. At some point we will reach the end of this imaginary row, so so Swing will start flowing components to the next row. So the components flow. If the screen of the window becomes wider, the components may be reusing the available space in the first row. So that's why the design will be like flowing. We will talk about the rest of the components pretty soon, but for now let's concentrate on the flow layout. Actually, no. Let's do a quick intro of other ones. Grid layout. Grid layout, it's if you want to allocate or arrange components in your container as a grid, rows and columns. What kind of grid you want to create? It depends on the screen, of course. You need to ask yourself, how many controls I need to put on the screen? In this example, say I want to have 3 labels, J labels, 3 J text fields, and a button. Total 7. So that's why I decided to use a grid layout that will have 4 columns and 2 rows. So it'll have enough room, enough cells. The crossing of the row and column is called cell, to allocate 8 components, right? But we have only 7, so fine. One of them will be empty. How to do something like this? You create a panel. In this case, it doesn't have to be a panel. You create a container. Then you create an instance of the grid layout. Then you assign this layout to the container, right? And after that, you're going to be adding components. Components will be added to the cells as you add them to the container. This will be the first cell, 0, 0 coordinates, 0, 1, 1, 0, 1, 1, 2, 0, 2, 1, and so on. So this is how it's going to be done. Finally, you will run the program, and it'll show this calculator. I think I misled you. It should be 0, 1, 2, 3, 4 rows and 2 columns, right? So 0, 0, 0, 1, 1, 0, 1, 1, 2, 0, 2, 1, 3, 0, 3, 1, coordinates of these cells. So if you will run this program, and the user will grab the corner of this calculator and will start stretching the window, the calculator will grow, but the layout will remain the same. I'll show it to you soon. If you don't want to allow this behavior, say you don't want to allow a user to stretch your calculator, then you can say set resizable false, in which case it won't be stretchable. Let's see it in action. So we need to download the source code of lesson 1, which I already did, from the textbook site, right? As we did in the previous lessons. And then we need to run the program called sample calculator. Let me go to Eclipse. Right click, import. I need to import existing project into workspace. And my archive is called lesson 8. It should be in downloads. Yes, lesson 8. Import it. And let's see what we got. Actually, let me do hello world first. Hello world. Right click, run as just one class. See there? Empty window. That's the one. Hello world. Hello world. Now, to be able to close the window, to make the button, this cross in Windows or this red bullet in Mac work, you need to do something special about it, and we'll talk about it a bit later, how to close the screen. For now, it's hanging in memory, that program, so I'll kill it from Eclipse. Let's do the simple calculator. Simple calculator is the one that uses flow layout, right? I showed this code on the slide. It's still one class. There's nothing too complicated about it. And let's see what we are importing. We're importing components which are sitting in the JavaX swing, and this layout manager, it's sitting in the package java.awt. Let's run it. Run as. See this calculator? Flow layout. Ugly looking calculator, right? But it is what it is. We decided to use the flow layout. So what do you expect? Let's see how it works. I will grab the corner of this window and we'll start stretching it. Look at this. See? It's wide enough to allocate 2 labels and 2 text fields in the top row, and it did it. Let me keep stretching. See, it allocates more because we have more room on the first row. This is what it means by the word float. It's floating. So, obviously this flow layout is not a good solution for many cases, but in some cases, if you want to say, I want to display the content on the screen no matter how big or small the screen is, maybe flow layout works for you. Now let's run a simple calculator with a grid layout. Again, we just covered it in a slide. Grid layout 4x2, one class. So that's the entire code. Again, you have to import the grid layout now. Right click, run as Java application. Now the layout is different. This is how it looks. Let me start stretching it. See? The window gets bigger, but the layout doesn't change. We still have a grid of 4 rows and 2 columns. It's not that great looking calculator, but it is what it is, what we programmed. Finally, if you will start entering stuff in there, will it work? First of all, it doesn't work. Second of all, it doesn't have any validation. We allow to enter any junk in these fields. When I click on the button, nothing will happen. Why? Because we didn't program event. We didn't write a code that would react on events. When I click on this button, the clicked event was fired under the hood. And if we would create a processing, the code that would react to this event, maybe something would change on the screen, but we are not there yet. For now, we are just trying to make the UI looking good. And it looks great, isn't it? Maybe not that great, but it looks as a grid, definitely. Okay, let's move on. Next layout is so-called border layout. What do we have in the border layout? In the border layout, the screen, the container will be divided into imaginary areas. South, west, north, and east, just like this. Again, these areas are imaginary, but north obviously is on top of the screen, south is on the bottom of the screen, and so on. If you believe that there is some content that should always stay on top of the screen, then add it to the north area of the container with border layout. Something has to be done, has to stay on the bottom, say some footer. Then add it to the south area. Maybe you want to have some navigation menu on the left of your window. Add it to the west area. And the good thing is that you don't have to specify all 5 of them. If you don't need to put anything in the east area, don't put anything. Then the center will occupy the all remaining of the screen to the right. If you don't need to put anything on the west, fine, don't put anything on the west. Then the center will take the entire space in this sandwich between the north and south. And if we will look at this calculator on the bottom, so what can we see, or what can we decide? We can decide that most likely we can use the border layout for our next calculator. In the border layout, what would you put on the north area? To me, it's clear that this display field should be always on top, regardless of how big or small the calculator is, right? So we will put it, maybe a text field or a label on the north area of the container. Next, what else do we see? We see a whole bunch of buttons over here. These buttons are the same. When you have a number of components which are the same in size, grid is a good candidate for layout. So what is going to happen over here? I believe what we need to do is to add a text field or a label on top, and we will add a panel in the center area. So north will go for the display field, and center area will go for the panel. In turn, inside the panel, we'll have a grid layout. So the J-frame, for example, will be controlled by the border layout, having north and center populated. But center will be controlled by the grid layout. So we'll have 2 containers with 2 different layout managers. Next example, or next layout manager, card layout. What is a card layout? Imagine a deck of playing cards. So only one card is visible, the card that is laying on top. So, but there are many cards in the deck, right? So that's what card layout is about. If you will change the top card, put it inside, then the other card will be visible, right? But only one at a time. So if you have a bunch of containers that you want to show, but only one at a time, then you can use card layout. Imagine a situation when you are using maybe some container with tabs, right? And you want to do navigation by clicking on tabs. So the user clicks on one tab, and you show one container with some content, one container. The user clicks on another tab, that first tab becomes invisible, and the other tab becomes visible. This is what it is for card layout. Absolute layout. As I said in the beginning, if you don't want any automatic control of the arrangements on the screen of your component, then use absolute layout. Absolute layout means don't help me out, I will take care of the layout myself. How do you ask for it? You say set layout null. Null meaning no layouts. In that case, you are on your own, please help yourself, and you create, for example, a button, and then you need to call set bounds on this button. And in there you specify the coordinates in pixels of the top left corner of the button. In this case, 100 to the right and 200 down. Everything starts with the top left corner of the window, which is 0, 0. And the width of this button will be 40 pixels, and the height of this button will be 20 pixels. So this is how it goes. And of course, you would need to put every other component that you need, just like this. Create an instance of the component and set the bounds of the components. And I also want to tell you, it's not either or. You can have a large container, say J-frame, with the content that is flowing, but there is a panel inside which always stays the same. So within that panel, you would turn off any layout manager, and you will have an image that is not supposed to be stretching or making or getting smaller. So you can combine layout managers. The other layout manager, probably the most complex to use, but it's pretty flexible, is called grid bag layout. Grid bag layout is using a helper, so-called a helper class, and with constraints. I'll show you the code pretty soon. So how this works? Again, let's take a look at the calculator. This is how the calculator looked like in the older versions of Microsoft Windows system. What if you wanted to create it? Create the calculator that look like this. Pretty recent we did this grid layout, right? No, what was it? It was border layout, right? So in the border layout we did something like this, and we added this panel to the north. The north panel, it was a text field to the north and the panel to the center. But you can do it differently, and actually this will be your homework. You can do it using grid bag layout. Grid bag layout allows you to specify, to fine-tune, so to speak, every control before you put it on the screen. For example, as I said, with the grid layout, you use it when you have components of the same size. But in our case, we have buttons which are having the same size, but this top control text field, it doesn't have the same size as button, right? Let's say it's 6 times wider. So what you can say, though, in the grid bag layout, you can say, I want to add this control into a cell. It's still grid, right? So we still operate with the cells. But the grid width is equal 6. You're saying it's not 6 in pixels, it's 6 times wider. You mean you're saying I am adding a cell to the coordinate 0, 0, right? But the width of this cell will be 6 times wider than other cells. What about the height? You can say the height is equal 1. The height is the same as the height of other cells. Fine. Then you put another, then you specify constraints of the other cell. Say, for example, this cell grid is with coordinate 1 and 0. What can you specify? You can specify, maybe you want to have some paddings inside the cells, again, size and so on. You'll see it. But the point is, before adding the cell, the content to the cell, you define constraints of this cell. And let's see how it looks like. You create an instance of grid bag layout, like as in this case. You set it to this container, maybe it's a JFrame or whatever. Then you need to create an instance of the second class. And this class is called grid bag constraints. Grid bag constraints is a place which it's not something that is visible, but you populate its properties with some values, and then you assign it to every cell. I mean, every cell can have its own set of properties, of course. So, for example, we create a new instance for this grid bag constraints, and then we say, I'm going to be dealing with this cell with coordinates 0x and 0y. Again, these are not coordinates in pixels, but cell number in a grid. So what do I say? I say the height of this particular the height constraint will be 1, so the same as other cells. The width of the cell will be equal 6 times wider, right? Then, how do you want to fill the space inside the cell? Do you want to fill it vertically and horizontally if the content is smaller than the cell size? Yes, I want to fill it horizontally and vertically, both. Then proportions of the horizontal space taken with this component, of the vertical space taken with this component. You can read about all that in the API documentation for the grid bag constraints class. Anyway, so you prepare all these constraints, and then you create this instance of the display field, and finally you need to assign constraints to this field. You're saying, I just prepared an instance that define all the constraints, and I want to apply these constraints to this display field, right? So this is what you do. You're saying to this GB is a grid bag layout instance, right? You're saying GB, take the display field, take the constraint that I prepared, apply the constraint so you know how to put it on the screen. And finally, we are adding this display field with assigned constraints to the window. All this you had to do for just one cell. If you have 20 cells, you need to do this 20 times. But again, flexibility is there. You can fine tune every cell and make it look differently if this is what you need. Next topic is events and listeners. As I said, there are different types of events. User generated, clicks, mouse moves, and so on. And system generated, paint event. The Java runtime decides that the window has to be repainted. Or maybe it needs to resize it as a result of some programmatic situation. So, a click on the button. If you click on the button, it'll fire an event. And what you need to do, you need to assign so-called listeners to the UI components. In this particular case, there is a class called Action Listener that is a good fit for reacting to click events. If you'd be needing to react on mouse movement, for example, you'd be assigning different types of listeners. For example, there is a mouse motion listener in Swing. So you need to ask yourself, what event do I care about, or which events? And you need to assign appropriate event handlers or event listeners. What's going on under the hood? How Swing renders or communicates with the user? So say there is somewhere data processor. It could be local on your machine. Maybe you are running a game, right? Candy Crush, for example, or Angry Birds. Everything is installed on your computer or maybe a phone or a tablet. In that case, you need to have somewhere some number crunching engine that will apply the logic of this game. As this is something that's not visible, but it's important. Then you will have some UI, of course, and we have a user. User will do something with the UI. User will try to move these candies on the screen. So as soon as something is happening on the screen, events are going from UI. Java runtime and its Swing component is running all the time. This is a so-called event loop. If event happens, an event will be happening all the time. If you will click on the button or tap on the button on the mobile devices, event is generated. Will it be processed? I don't know. If your program has an event handler, then it will be processed. So, event arrived. This event loop is picking up the event and it tries to find, do I have a listener for this event? Yes, I do. It'll call the listener. Maybe the listener will invoke some data processing, maybe local. Maybe it'll need to make a request to the server. Then the result of the data is coming back and it has to be displayed again. So this data processing unit will need to say, I want to refresh the content of this UI component. Again, this loop is always watching. Is there the need to refresh the screen or modify the screen? Yes, it is. So it'll do this and it'll modify the UI so the user will see the result. And this event loop is going all the time. And there is a special so-called thread, processing thread, that is taking care of all changes on the UI. So, but the point is, there could be many events that are coming from the UI. all these events are being placed in a queue and are processed by this event loop sequentially. And on the other hand, if the data is coming in that should be displayed on the screen, on the UI, on the graphical interface, then again, they are placed on the queue and this event loop is picking up them one by one. Let's look at the example, action listener interface. As I said, it's a good fit for processing click events. We need to learn a new buzzword, callback. It's a technical term, which means that if we say that there is a callback method, it means that we are not going to be calling the method on ourselves. Our program will not be calling it. The environment will call the method in our program. It sounds weird, right? So we are saying this is a method, but I will never explicitly call it. But when the time comes, the Java runtime will call it for me in my program. So callbacks is a code that you specify but never call. Why would you need something like this? Because this is how event-driven programming works. You try to think, what events do I care about? If I care about event button clicks, then you create a callback method. Technically, you're saying, here's a method for you, Java runtime. I don't know if the user will ever click on the event, but if they will, then at least you will know what to do. If the user will click on the event, on the button, and you created event listener for it with a callback method, the callback method is, in this case, action performed, then Java runtime will call this method for you and execute the code that you put in there. If you care about mouse events, then you would need to use another listener, maybe mouth motion listener, and then you would need to see what callbacks have to be implemented there. But the simplest one is action listener, which is an interface, and it declares in there only one method, action perform. So we know if we are dealing with interfaces, and if my class, say calculator, will implement an interface, it's my goal to implement all methods declared in there. In this case, it's only one. So for example, let's say to separate UI, graphic UI code and processing code, I will create a separate class. So one class will be called calculator.java, right? The other class will be called, in my case, I decided to call it calculator engine. That class will not have anything to do, any GUI components, but it has processing. On the other hand, calculator class will not have processing logic, but it'll have GUI components. These two classes will talk to each other, and I'll show you how. For now, let's assume that my class with business logic will be called calculator engine, and in there I will be declaring listeners to the event or events. So calculator engine class implements action listener, which means that I must write some code into the method action performed. Again, this is a callback method. You will not find any place where I explicitly invoke this method. It'll be called on the instance of calculator engine if the user will decide to click on a button. That's the nature of any callbacks. And I believe it's a good time to talk about a design pattern called MVC, or Model View Controller. Design patterns are usually, they are patterns, of course, which were created based on the experience of many programmers that had to solve similar tasks. On many projects, different programmers in different countries, they had to do repeatedly the same things all over and over again. For example, they had to split the application code into areas. One area that deals with UI, the other area that deals with processing of the event that happens on the UI, and the other area maybe that deals with data. Maybe it reads the database, maybe it reads the files, or maybe it saves in the database or files. So the idea was, let's create a pattern and call it MVC. So at least when programmers talk to each other, they can use these terms, and they will say, you know what, we will use MVC pattern in this project, which could mean that we will create class or classes that will be responsible for views. Letter V is for views, for the GUI. Model means that we will create some place which will be responsible for model. Model is the data, always the data. Maybe model is an array with some data, or maybe it's a variable, or maybe it's something sitting on the server, even sitting in the database. I mean, something that is populated from the database. Anyway, model is about data. And controller, C, controller. Controller is something that brings together the model and the view. For example, we have a calculator. It plays the role of the view in our design pattern. Some events are happening, and the second class, I decided to call it calculator engine. It'll play the role of the controller. Processing is in there. If I had some data, which I don't, in this example, in this calculator, then I would create another class and I would store data in there. Right? Imagine if it's a game and you want to store scores of the players. Then maybe you would introduce another layer or another class that would belong to the model tier. Model, view, controller. For now, remember that. We'll have a couple of situations when we'll be talking about MVC again. But this is pretty much the essence of what MVC is. Separation of classes, or separation of code, I would say. Some code deals with viewing, some code with data, and some code with processing. Let's see. How do you register GUI components with their event listeners? First of all, after you will create a class calculator engine that implements action listener, inside the calculator class, you will instantiate it. And check this out. Calculator wants to create its engine, and it passes the reference to itself. Obviously, you understand that we are dealing with constructor over here. And what can we guess by looking at this code, at this line? We can guess that there is a class called calculator engine which has a constructor which takes one argument of type calculator, because we are sitting inside the calculator now. So calculator expect to get a reference, calculator engine expects to receive a reference to the calculator. Why? Because it wants to update the UI with results of processing. So calculator is nice looking UI. The user clicks on the button, event happens. Who is the listener? Register listener. Calculator engine. See, we are saying, say we have a bunch of buttons inside the calculator. We are saying to the button 0, your action listener is calc engine. So if something happens to you, the Java runtime will try to find and invoke the callback from action listener. Which callback? Action performed, right? So whatever code you will write inside the action performed will be invoked. And again, button 1 has also an event listener, so it needs to react to events with the button. Where is the code to react? Inside the calc engine, and so on. Eventually, inside the calc engine, we will do some calculations, and we want to display results in the screen, right? So we need this instance of the calculator engine needs to know where is the view, where should I send the data, right? So, and that's the reason why during creation of the instance of calc engine, we passed the reference to the view, to the calculator instance. So by using this reference, the engine will be able to send the data to the view. Now let's see. The calculator view will have a bunch of buttons, and the user can click on any of them. And of course, depending on which button the user clicked on, the processing will be different. Let's see how it goes. Class calculator engine implements action listener. Because of that, we have to write the code in the action perform. Action perform will be called, this callback will be called, and the Java runtime will pass parameter, action event in this case. Action event will have inside some useful information about the event, what happened. So we know that whenever Java runtime will call this method, we'll get this argument, and we can query this argument. We can ask this object, what happened? And getSource method will tell you what was the source or the reason of the event. If you have 10 buttons, we can figure out which button was triggering this event. Look at this. We call it casting, right? You learned it already in the previous lessons. We are saying, I know that getSource method can return any object, but I definitely know that on my application it's going to be nothing else but JButton. So we cast it to JButton, right? And then we try to query, what's the text on you? Every button will have some text, 0, 1, 2, 3, maybe equal. So we are querying, we are trying to get the label on the button. We are saying, give me your label. And then in this case, I just display it just to prove that, yes, I reacted on the click and I know what button was clicked on. So there is a special class in Swing called JOptionPane. If you want to display a pop-up, a dialog as we call it, a message to the user, you say JOptionPane dot show dialog. There's a whole bunch of methods to show different types of pop-ups. And in this case, I am saying show confirm dialog. It'll ask for confirmation. A little message box. It will have a button to confirm. So in there, I will show you pressed. I will attach the label that I figured out, and just a test. So I hope you get the point. But now again, I want to stress this situation: how two instances of objects can talk to each other. We need to pass references of one object to the other, as in here, calculator engine. Check this out. We are instantiating a class B from class A, calculator engine from calculator. And we are passing this, which points at the instance of class A, calculator. What are we doing there? We need to, inside the constructor of this calculator engine, we need to store it somewhere in the variable, this reference that we receive. So later on we can use it. Say we will create a variable parent inside the calculator engine, and we will assign this reference to the parent. Right? The time came, we calculated, maybe they wanted to add two numbers. The calculator engine added two numbers together, and it needs to send back the results to show it on that display field on the UI. One of the way, and I marked it as a bad practice, really, really bad. But I want you to see the bad practice. So if you know that the class calculator has a field inside named display field, right? And if we want to get the content of that display field, or maybe to put something in there, we can use getText or setText from there. So what's so bad about it? I am sitting inside the class calculator engine, and I want to get the content of that field, and I know that the field is there. So what's so bad? The bad thing is that we need to use so-called encapsulation. We need to hide data. We need to use public API. We need to expose only the things that are safe to expose. Like with the car, remember, on the car panel you have only so many handles and 3 pedals down there and the wheel. But there's tons of what's going on inside. And we don't want everything to be exposed. What can go wrong if I will use this? Parent.displayField.getText. What if later on I will decide that in the class calculator I don't want to use a simple display field. I want to use maybe a different component, text area. So it'll, or maybe a drop down. So it'll keep remembering all the actions that I did in this calculator. I hope you've seen some of these calculators, like little white tape that is going out where all the history of calculation is being saved. So if I decide to change the displayed field in the calculator, and if I use something like this in the calculator engine, then I will need to change the calculator display text, one control for the other, and then I need to come here and change this code as well, because maybe this drop down doesn't even have the method getText. See, breaking, so changing something in class A will break code in class B. Why? Because the class B was trying to use directly internals of the class A. So what's the better way? The better way is to create a public API on the calculator class, in this case, class A. So you can create a method, a public method on the class calculator, set display value or get display value. See, in this case, we are not revealing to the world what components do I have inside. I'm saying, if you need to get the value from the display field, call this method for me, on me, and I'll give it to you. Where is that? It's none of your business. I'll give it to you. If you want to give me the result of the calculation, nice. Call set display value on the class calculator and give me what you want to show. Where exactly? None of your business. I know where to show. Do you feel the difference? If in this scenario I will decide to change the control, the GUI control that I use inside the calculator to display data, I need to change it only inside the class calculator. The other classes, the engine was using get display value, set display value. It'll still be using them. They are not broken anymore. But of course, how do I set display value? I will have to fix, but it will be done locally inside the class calculator. So always think what should be private, what should be public. What public interface you want to give on the class to make sure that the minimum of internal information is exposed. And this is how this can be done. We have a private field, display field, right? And we have 2 public methods, set display value and get display value, right? So what do we do inside? It's our business. The rest of the world will not know that I am actually, what type of the variable display field is this. Why? Because it's private. Okay, walkthrough number 2. Download and import the code from the lesson 9 and review it with instructor. Let's do it. Let's do it. So I need to go to this textbook. To this textbooks, right? Download code. Lesson 9. Where is lesson 9? It's right there. Click to download. It is downloaded. Going to Eclipse. Let's import it. Import. Existing project into workspace. Fine. Browse. Lesson 9. Open. Finish. Alright, we got lesson 9. Let me close these files. So what do we get there? Calculator and calculator engine, right? Let's see. So what our slides instruct us to do. Run the calculator program and see if the button reacts on the click. And actually we need to review the code. Alright, with instructor. I am the instructor. So let's review the code. Today I am the instructor. Maybe tomorrow you will be the instructor and I will be your student. So class calculator, it has a whole bunch of buttons and a panel. Right? Now it has this public API as we just discussed to get and set display value. We have a constructor which creates a panel, line 41, which creates a border layout and assigns to the panel. Then we create a display field and add it to the north area. Remember the north area of the border layout. It will always stay on north. Then I create a whole bunch of buttons and put them inside the panel. The panel inside will be controlled by the grid layout, right? So this frame, the J-frame will be controlled by the border layout, but the panel inside will be controlled by the grid layout. Border layout for the frame and grid layout for the panel. Then we throw all these buttons inside the panel. Then we create the instance of the calculator engine class, passing the reference to me calculator. And then we added a bunch of listeners to several buttons, 0, 1, 2, 3, 4. Not all of them, pay attention, some of them. I did it on purpose. Then I added the panel to J-frame. And sorry. Yeah, I added the panel to the center, right? Remember that border layout. Then I created a new frame with a panel. Finally, what do? I do frame pack. Frame pack, actual method pack means you have a container, make it as small as possible, but big enough to allocate all components that are in there, like a minimalistic approach, and make it visible. Done. That's the UI. Check this out. There is no processing. There is only UI, model view controller. This is a view. We are not processing anything in there. We just added buttons, laid them out nicely, and we said, who is your processor? Who is your listener? We created an instance of calculator engine and give it and pass this to it. And do whatever you want with my data. But also, we provided them the wheel, the pedals in the car, right? We provided them public interface so they can get data from me and they can give data to me. Where I'm going to put it? In the private field on top of the calculator. Let's go to the calc engine. It's a small class. Implements action listener, hence we must implement the callback action performed. Constructor. What do we do in the constructor? In the constructor we are receiving the reference to the parent. I use the word parent. It's not technically a parent, they are siblings. But whoever created the engine, I call it a parent. So I'm just storing the argument in this parent. Parent is having type calculator, right? Because calculator is a guy who will be always creating engine, and calculator is a guy that needs data from the engine. So the variable parent remembers where the instance of the calculator is. And whenever the callback will be called, when? I don't know. Whenever the user will click on it, on the button. Will this callback always be invoked? Maybe not. If the user will never click on the button. Or if the user will click on the button which does not have a listener assigned to it. Right? So, but if everything is hunky-dory and the user clicked on the button, we need this method will be invoked and will be given an object of type action event, which inside will have some useful information. In particular, I can call the method get source, so to figure out which button was clicked. And then I want to take, based on what was the content of the button, it was 1 or 2 or 3 or 4, I want to show it, right? So the user clicked on the button, I want to display it in the field. So, but I don't want to erase whatever was entered before. So what do? I say to the parent, please give me what you already have for now, by now, get display value, right? And then I get the label from the clicked button, and then I concatenate, I attached whatever was there already entered in the display field. I attach a new label from the newly clicked button, and I send it back to the parent. I call the method set display value. I concatenated, I attach to the end the newly clicked digit, or maybe it wouldn't be a digit, maybe it will be a dot, a period, and I send it back to the parent. The parent will receive a method called set display value. Sorry, this one. Set display value, and will obediently put it on the screen in the display field, whatever the engine gave to it. Easy. Easy peasy. Right click, run as Java application. Beautiful, beautiful calculator. Right? 1. It works. 2. It works. 3. It works. How about 9? No. 8. No. 0 works. 5. No. Why? I guess you know why, right? Why? Because we forgot. We are stupid. We forgot to assign the listeners to every button. We assign them only to the button 0, 1, 2, 3, and 4. That's why other buttons don't work. Events are being triggered under the hood. Java runtime says, my job is to trigger event. The user clicked on the button, I will trigger an event. But since there is no listener, this event is not being handled. This is how it works. Moving on. Other layouts. Box layout. Box layout, imagine you have a box, narrow box, and you put in there stuff. So everything that you put in there goes on top of each other. So in this case, actually, to be honest, you can do it either vertically or you can have a horizontal box, so to speak, when you push stuff in there. But the point is, everything that you add will be laid out. In this case, it's vertical. Let's see. Create a frame, right? And by the way, this is something that we never did before, but something that we need to do. Remember I told you, when we created this hello world, when we click on the little red dot in the corner on Mac of the window, or maybe if you are using Windows operational system, you will be click on that little cross on the title bar of the window. It won't work unless you do something about it. One of the ways to do that, to make it work, is when you create the frame, you need to say set default close operation. And you need to say jframe.exit and close. So whenever they will click on this little button or little cross in Windows, the window will be closed and the program will be finished. Anyway, set content to the pane, right? We added the content. And we said, I want to set layout, right? Oh, see, this is improperly laid out on the slide. It should be pane.add content to the pane. Or, let's see what we do over here. Yeah. So then we say pane.set layout. On the fly, we create new box layout for the pane, for the variable pane, right? And we just add the buttons in there, and the buttons are falling down in this box, one on top of the other. This is a link that you can read to learn more about the box layout. And this is pretty much it for today. Homework. I want you to get familiar on your own with the grid bag layout. And then do the assignment from the textbook from lesson 8 and 9. It's going to be about the same calculator, but I want you to replace to change the way you do layout of the calculator class, of the GUI. We've been using border layout with a panel inside with a grid layout. But I want to replace it. I want you to create an instance of grid bag layout and an instance of the grid bag constraints, and the entire calculator should be handled or managed by the grid bag layout. Of course, you're welcome to read tutorial on Swing, which is published online. And when everything is worked, try to see if you can do something with the box layout. Can you apply it over there somehow? And so on. Finally, as an additional read, I highly recommend you to learn about another design pattern. We already learned about MVC, Model View Controller, but there is another pattern which is applicable to the event-driven programming, and this pattern is called Observer. If you will learn it, Lars Vogel is a person who publishes lots of nice Java tutorials, and this is one of them. So read how you can create a class that performs the roles of observer, and there is something called observable. So if you need to program classes when one class can send notification to the other about some important event, so you can use observable pattern. So one class will register with the other, and it will be watching or waiting for some events. That's it for today. Thank you very much. My name is Yakov Payne, and it was the lesson number 5 from my Java training, Intro to Java training. Thank you very much.